Hi, good morning students. Today we will learn how to sketch a cubic function. Now a typical cubic function will be given in this form. Y is equals to ax cubed plus bx squared plus cx plus d. Now we can divide this into two categories. That is, what happens if a is greater than 0 and what happens if a is smaller than 0. Now under each of these category, for a is greater than 0, you have three scenarios. One of them is you have one root and the other one is two roots and the last one will be three roots. Now likewise for a, when a is smaller than 0, you can classify it into three subcategories. One of them is one root, the other one is two roots, and the third one has three roots. Now, how will the expression of ax cubed plus bx squared plus cx plus d be like if it is a one root? Now, please take note, a must not be equals to 0 for all this scenario, because when a is 0, the function is no longer cubic. For single root, your expression can be broken down into y is equals to a x minus b, or say p cubed. Now p can be 0, so it can also be of this form. Now it can also be of y is equals to a into x minus p into x squared plus qx plus r. Now, please take note, this one, for this graph, you must have no roots for x squared plus qx plus r. That means the discriminant of this quadratic function must be less than 0. Now you realize that each of these, if you equate to 0, you will only have one root. Likewise, for this case, your expression will look exactly the same. And the last one will be y into a into x minus p into x squared plus qx plus r. Now let's look at how the expression will look like if it has two roots. Now it will look something like that. Y equals to x minus p into x squared plus qx plus r. But this you can factorize. Alright? There's a difference. This one, there has no roots, so you cannot factorize. So if you factorize, what will it look like? A into x minus p into x minus m squared. You realize that you have two roots here. So this one, you must be equal roots. So your discriminant of this expression, x squared plus qx plus r, must be equals to 0. Now, likewise for when a is smaller than 0, your expression, your graph therefore can be broken down into these two. Now what happens if there are 3 roots? Then you realize that this expression, all right, can be factorized into this form. Y is equals to a x minus p into x minus q into x minus r. Likewise for this. Now, how will your graph looks like when it has only a single root? Now, before that, we look into the 2 scenarios first. One of them, a is greater than 0. The other one is a is smaller than 0. In my earlier lesson, I have already taught you how can we deduce the graph of a x cubed. Now for a x cubed, your graph will be of this shape when a is greater than 0. Now this will be of this shape. I'm running out of space. All right, when a is smaller than 0, it will be of this shape. Now what happened for these 2 cases first? Now if a is greater than 0, the shape of these 2 graphs, these 2 classification, under graph that is under these 2 classification will be of this form when a is greater than 0. This one, these 2 will be of this form. Now, sometimes your teacher will ask you to memorize. When a is greater than 0, you will take this. When a is more than 0, is take this. Now, as for me, I find that it's very tough on me because my memory is really bad. So for me, it's easier for me to deduce. All right. Now, what happens if a is greater than 0? Look at this. Now, I give you an example. Let's consider this expression first. Y equals to x cubed minus 100x squared minus 10x plus 1. Now, when x tends to infinity, what happened to this expression here, your y? Your y will tend to infinity as well. Let's say x is equals to 100 or 1000. Let's say x is 1000. Then realize that this is much bigger than the sum of these 2 because this is cube. Now, so when x tends to infinity, your y tends to infinity as well. So your graph has to be this way. It can't be this way because this one, the graph is going down as x increases. All right, as x increases this way, as you move along the x-axis to the right of the x-axis, you realize that now this graph doesn't stop here, it continues. All right, since it's going down, then as you move, then you will find that it tends to negative infinity. So for this, when x tends to infinity, your y tends to negative infinity. All right, so for this case, you realize that your graph has to go upwards. When x tends to infinity, your y since y also tends to infinity, So your graph has to be going upwards. So I find it easier to deduce rather than to memorize. Likewise for one root, when a is greater than 0, your graph has to go this way because when x tends to infinity, your y tends to infinity as well. Okay? Actually go both ways. Maybe I draw the arrow this way. So for single root, your graph will look something like that. All right. The x-axis can be anything here, anywhere. All right. Depends on your values of p. Now, for two roots and three roots, the shape of the graph is the same. It's where the location of the x-axis. The difference is the location of the x-axis. Now let me show you by drawing a typical shape of a cubic function that has two roots and three roots. So for a two roots function and a positive a, your graph will look something like this. Now for a function that has three roots, it looks something like this too. Now, how about the shape of this graph when it's a single root? The shape will look something like this. And for two roots and three roots, your shape of the graph will be like this. Now, for two roots, there are only two possibilities. Your x-axis has to be here or here. Because if the x-axis is above this, you will find that above this upper dotted line, you will find that there's only one root. If it's below this, the lower dotted line, you only have one root, but the expression has two roots. So it has to be on the dotted line, because anywhere between these two dotted lines, it has three roots. So this will be your x-axis. Likewise for this. Same goes to two roots. Same goes to when a is smaller than 0. That's where your x-axis has to be. Now what happens if your graph has three roots? Then your x-axis must lie in between these two points. This is where your x-axis must be. Likewise for this. Okay? Now, there's one thing I need you to remember, especially for students who don't take A Math. Now, you look at this m, x equals to m. Remember, when this is a square or a cube, in this case is a square, all right? Your x equals to m will be a turning point or the vertex or one of the turning point of the graph, okay? So your m must be here or here. Okay, that's one thing I need you to memorize, to remember. For students who take A Math, you can use your differentiation, all right, and prove that, or your calculus, your knowledge in calculus, to find that m will be one of the turning point. Now, if you don't take A Math, can you prove that this is it has to be on a point maximum or minimum point of the graph? It's possible, but it's quite tedious, so I will not be touching on that. Now, to make sure you understand better, I will then move on to give you an example of a 2 roots and a 3 roots graph, and we will see how are we going to do a sketch for that 2 graphs. So please stay on and continue watching the video. In this question, you are asked to sketch these 2 graphs and also to indicate the coordinates of all the x and y intercepts. Let's start off with part 1 of this question. You are given a graph y is equals to 3 into x minus 4 into x plus 1 whole thing squared. Now, by looking at this graph, should it be this, look something like that, or should it look something like this? Now, look at this graph, you find that the coefficient of x cubed is positive. In this case, is 3. So when x tends to infinity, your y also tends to infinity. So your graph has to be of this shape. Now, what are the roots? You equate this to 0, you will find that the roots are x equals to 4 or minus 1. Now remember earlier when I'm teaching you the graph, when you see a square, it has to be on a turning point. So you have 2 roots here, one is a minus 4 and one is one is minus 1 and one is 4. So this should be minus 1, all right? And this has to be 4. This has to be minus 1. If this is minus 1, or if this is minus 1, because minus 1 is a turning point, x equals to minus 1 is a coordinate, x coordinate of a turning point. Now, if minus 1 is here, then the other roots is less than minus 1. It cannot be 4. So minus 1 has to take this turning point on the left. So your graph will look something like this. Okay, then you draw it on the actual question sheet. Now let's look at where it cuts the y-axis first, perhaps. All right, you put x equals to 0. All right, maybe we find where's the y-intercept first. So you put x equals to 0 for the y-intercept. What do you get for y? You get minus 12. All right, so this is, let's say this is minus 1. This will be 4. All right. Your graph will look something like this. Okay. and this is minus 12. Now how about the next graph? You find that this coefficient of x cubed is negative. So your graph will look like this, the one in blue. Now, where are the roots? The roots are 4, 1, and minus 2. How I find the roots is if I equate y to 0. Alright, so if y is equal to 0, the roots are 4, 1, and minus 2. And what about the y-intercept? You put x equals to 0. When you put x equals to 0, your y will be equals to what? Your y will be equals to minus 2 into 2 into minus 1 into minus 4. And you get minus 16. So your graph over here, you have roots minus 2, 1, and 4. Alright, and your graph will look something like this. Okay, and this is minus 16. Now you're asked to put the coordinates. So in this case, I think I left out the coordinates just now. So you cannot just put minus 1. So it's minus 1, 0. Because coordinates have x and y. So this will be 0, minus 12. And this one 4, 0. Now for the other graph, it will be 4, 0. This one is 1, 0. This is minus 2, 0. And this is 0, minus 16. With that, we come to the end of this section. I hope you have picked up something from this video. Thank you for watching. Hope to see you in the next video.